Good evening, Bearcats. Just going to go ahead and get started right now. We're going to start 2.7, which is on nonlinear inequalities. We're going to discover something about critical numbers, which will help us determine the solutions to nonlinear inequalities. We're going to just go through a few examples that are actually in that will give you some base for your classwork, and you'll be working on this in class on Thursday. I may add a few more examples tomorrow evening on the video, so make sure and check in. But this will be the basis for what you'll be doing in this section. All right, we're going to go ahead and get started, and I'm going to start with example 1. Okay, the problem we start with is x squared minus x minus 6, which is less than or equal to 0. Less than or equal to 0. This is a strict inequality. There is no equal sign here, so it's just less than 0, not equal. I think I may have said that, but it's not. It's just less than 0. The first thing we're going to do is we're going to find something called critical numbers. This will help us determine our solution to this inequality. The next thing we're going to do is we're going to factor to be able to find those. So it's the zeros of the factors that are going to be our critical numbers. So in this case, it's a pretty easy factoring problem. You would have x and x. You would have 2 and 3, be negative 3 and positive 2. And therefore our solutions, our critical numbers, would be negative 2 and 3. Negative 2 and 3. Then we're going to use a number line and some test intervals to determine our solution. So if I have negative 2 here and 3 here, we're going to test each interval. This first test interval, and these are test intervals. The first test interval, of course, over here is from negative infinity to negative 2. The second test interval is from negative 2 to 3. And the third test interval is from 3 to positive infinity. And of course, then we actually have to test our critical values as well. All right. Here we go. The theory behind this is if a value or a number, an x value, an x number, in any one of these areas, any one of these interval areas, if one of the values make the equation true, then all of the values in that particular area would make the equation true. So that kind of helps us out. So let's go ahead and start testing. Now, I always test 0 first because it's the easiest number. Some people like to test right to left. Some people like to test left to right. It does not matter. So I'm going to just start right here in the middle, and I'm going to use 0 as my test since it's between negative 2 and 3. I'm going to go back up to my problem. Something that's going to help you get there a lot quicker, you don't really have to use an exact value. In between two numbers you do, but when it's out there in infinity, you can just think of really large numbers or really small numbers. So we're going to kind of go through. Sometimes using the factored version of when you substitute in is also easier. So think about this. If I put a 0, I'd have a positive 2. If I put a 0, I have a negative 3. If a positive times a negative, which is negative, is a negative number less than 0, I believe it is always less than 0. So all the values between negative 2 and 3 would be solutions to our nonlinear inequality. Now, we also have to make sure that there are other regions that don't make it true. So let's test something on the right side, which would be 3 to infinity. Let's just say it's a really large number. If I take a really large number in for x and add 2, it's going to be a really large number, if a positive number. If I take a really large number and subtract 3, it's going to be a positive number. And a positive times a positive is a positive value. Is a positive value less than 0? No, it's not. So we get a sad face there. Okay, and we're going to go over here and test the left side. Really, really, really small number. A really, really, really small number, or you can think of a really large negative number, which is a really small number, would be a negative here. over here, a negative minus a negative is more negative. Negative times negative is positive. Positive less than 0, don't think so. So also, again, not true. So it's those values in the middle. Now, we do want to test our critical values real quick, and they become more important later on. If we were to plug a negative 2 in here, that would make this 0. And 0 times 0 would be 0, and this would give us 0 is less than 0. That's not true. So we cannot count our 2. And same thing for 3. If we put a 3, we get a 0. 0 is not less than 0. We cannot count the 3. So therefore, our solution set for this problem would be all the x values between negative 2 and 3, but not including 2 and 3. But not including 2 and 3. All right, let's go on to another example. Our next example is x squared plus 2x is greater than or equal to 3. This time we don't have 0 on the other side. Before we get started, so we can use the same philosophy, we're going to move 3 over here. So when we do, we get x squared plus 2x minus 3 is greater than or equal to 0. All right, and we're going to go through the same thing again. We're going to go ahead and factor x and x, and this would be a negative 3, or a 3 and a 1, so it'd be a negative 1 and a positive 3. So that's a negative 1 and a positive 3, which would give us a positive 2. And negative 1 times 3 is negative 3. All right, so once we do that, then we've got our critical values at 1 and negative 3. And we're going to put those on a number line so that we can do our test interval. So here's our number line. And our critical values are at negative 3 and 1. So we're going to do our test intervals here. So again, our test intervals are going to be from negative 3 to, from negative infinity to 3, from 3 to 1, or from 1 to positive infinity. So let's just go ahead and go left to right this time. Let's think of a really, really small number. If we have a really, really small number for x and we subtract a number, it's going to be even a smaller, it's going to be a negative number. If we have a really, really small number here, a really large, like a negative 1,000, it's going to be a negative. We're going to have a negative times a negative. A negative times a negative is a positive. Is a positive greater than or equal to 0? I believe it is. So yes is the answer here. We get a little happy face. Let's go ahead and check between negative 3 and 1. So between negative 3 and 1, the famous one is 0. If we plug a 0 in for both of our x's, we'd have negative 1 times 3. Is negative greater than 0? No, it is not. That does not work. And then let's test one on the right side. On the right side, if we pick a really large number, a really large positive number would give us a positive result. A really large positive number plus more positive would give us a positive. So positive times positive gives us greater than or equal to 0. Yes, that would be true. And so we would have another really happy moment. All right, so our two intervals then are between negative infinity and negative 3, and between 1 and positive infinity. But we really need to go ahead and check out our critical values to see if we're equal there, if it makes it true. So if I plug a negative 3 here, that gives me a 0, and 0 is greater than or equal to 0. So we would get a hard bracket for this because negative 3 would be a solution. The same thing happens with 1. 1 minus 1 is 0, so that would be, and that would be greater than 0 would be greater than or equal to 0. So again, we would get a hard bracket. You can either use the U for union, which is really important when you go to college, especially like a college algebra class, or you can use the word or in here. But that union symbol is a really important one. Okay, we're going to take on another example. All right, our next example gets just a little bit more complicated in the numbers, but not a lot, but we want to take a look at these. All right, so again, we're going to find our critical numbers, and to do that, we're going to do some factoring, and I see here we have a 4 and an x squared in common over here, so we're going to extract a 4x squared, and we would have an x minus 3 greater than 0. All right, so now we're going to get our critical values. Our critical numbers. Our critical numbers for this one would be, our 0 would be 0. For this one, our critical value would be 3. So we have 0 and 3. Therefore, we have 3 intervals We have negative infinity to 0. We have between 0 and 3, and we have 3 to positive infinity. All right. This is a strict inequality, so it will probably not include any of the real numbers, but we'll double check them just in case. Because they'll make them zeros, it can't be equal to 0, so that will not be included. All right, let's go ahead and do our test points. We'll go ahead and go left to right again. So if we go left to right, let's take a really small number, or a negative number. So we take a negative number and square it is positive, and times 4 is positive. So this whole term right here becomes positive. Let's take the factor. If you take a really large negative number and you subtract it, that's a negative. And so negative times positive is a negative. Is a negative number bigger than 0? I don't think so. So this does not work. All right, let's try in between 0 and 3. Let's just pick 1. That's an easy number. If I plug in 1, that would be a 4. If I plug in 1 minus 3, it would be a negative 2. That would give me a positive times a negative, which is a negative, and negative is not greater than 0. So this would not be true. All right, let's see if we have any answer. We could have no solution, I guess. Really large number. If we take a really large number and square it, it's positive. Times 4, it's positive. Take a really large number and subtract 3, it's positive. Positive times positive is positive. Is a positive number greater than 0? Yes, I believe it is. And we have our solution. And that goes on forever. Okay. All right, we've got 2 more examples. Let's take a look at the next one. The next one is x plus 5 less than 0. X plus 5 less than 0. And I also want to take a look if it was not a strict solution, what that would be. Oh, sorry, it's x plus 5 over x minus 3. I kind of left part of that out. So now we even have a rational expression that we're able to use this same format for, except this time we're going to find the zeros of the numerator and the zeros of the denominator, and we're going to make those comparisons. So I'm going to go ahead and start my number line. And the 0 of the numerator would be at negative 5. The 0 of the denominator would be at 3. So we're at negative 5 and 3. So that's how our intervals break out. So we're from negative infinity to negative 5 to 3, 3 to positive infinity. All right, so now let's go ahead and see what happens if we plug in a number from each interval. So let's take a really large negative number. A really large negative number plus 5 is still going to be a negative number. So the top would be negative. In the bottom, we have a really large negative number, and that would be minus another number, that'd be negative. Negative O negative would be a positive. Is a positive number less than 0? I don't think so. All right, in between negative 5 and 3. Well, 0's in there, which is nice. If we plug a 0 for both of these, we would have 5 over negative 3. That's a negative number. Is a negative number less than 0? I believe it is. So we know that in that interval, we would have solution. When you get to those critical values, you have to think, if I plug in negative 5, that'd make a 0 in the numerator. Okay? 0 in the numerator just makes the whole fraction 0. Is this 0 less than 0? No, it is not. So negative 5 will not get included. For 3, it wouldn't matter. Even if this was a strict one, for 3, it would never be a part of the solution, because 3 minus 3 would be 0. You'd create a 0 in the denominator, which would be undefined. This would create an undefined term. So it would never be. And for this particular problem, there was no inequality, so we are just between negative 5 and 3. So our solution is between negative 5 and 3 with the proper notation on the parentheses instead of a bracket. All right, last example of the night. All right, this is going to take us just a minute. It takes a little bit more time. This is x plus 12 over x plus 2 greater than or equal to 3. All right, this is going to put us through some really good skills. So you may want to pause here. I believe this will be all the video I have for you for 2.7. You will work the problems off your calendar in class on Thursday, and then Thursday night I will have another video and we will start our appendix work. And so if I do that Thursday night, then we can work in our appendix on Friday. So you may want to do that and take on this one tomorrow night, or you may want to go through and do all the problems you can and then go back and take a look at this as a refresher. But this also gives us a lot more information about some review skills that we've been doing. All right, before we can use that whole theory, we do have to have it less than or greater than or equal to 0. So we are going to need to move the 3 over. When we do that, we get x plus 12 over x plus 2, and we're just going to say minus 3 over 1. And that would be greater than or equal to 0. The next thing we're going to do is we're going to have to find common denominators to be able to write this correctly. So our common denominator should be x plus 2. That means I need to multiply the top and the bottom over here on the right by x plus 2. So I'm just going to write out here x plus 2. All right, well that will be 3x plus 6. 3x plus 6. Oh, sorry. This 3 is negative. Take that really care. So distributing that negative, it would be a negative 3x, negative 3x, and negative 3 times positive 2 would be a negative 6. Alright, the next thing we're going to do is we're going to combine like terms at the top. We have a negative 3x and a positive 1, so we have a negative 2x. We have a positive 12 and a negative 6, so we have a positive 6. And that's all over the original denominator of, which is, just make sure you realize it's in several places. That's the original denominator of x plus 2. And then that now, since the 3's been moved over, that is greater than or equal to 0. Greater than or equal to 0. All right, let's go ahead and factor like we've been doing. Now we look a little bit more like our last problem. So you can take out a negative 2 and have x minus 3. And you can have that over x plus 2. All right, you can't cancel anything, but you can use the factors to help us determine our solution. So I'm going to go ahead and start our number line, and we need our critical values. Our critical values, the numerator would be at positive 3, and a critical value in the denominator would be a negative 2. So I'm going to put a point in negative 2 and a point at 3. And now we're going to use our test intervals between negative infinity, negative 2, 2 to 3, and 3 to positive infinity. All right, let's see what happens here. Remember, we're focusing on this part of the problem now. And we found our critical values. So if we take a really small number, a really small negative number, minus a negative, that's going to give us a negative at the top, times negative 2, that's going to give us a positive at the top. So this would be a positive at the top, and in the bottom, for a really big negative number plus 2 is going to be a negative at the bottom. So overall this is negative. And is a negative number greater than or equal to 0? No, it is not, so this is a no. Okay, let's go in between the negative 2 and 3. That would be 0. 0 makes it easy. If you plug in a 0, you get negative 2 times negative 3, which would be a positive value. In the bottom, you plug in a 0, and you get a positive 2, and that's a positive number. So it sounds like to me that all the positive numbers would work. So both cases, a really big positive or a positive number be greater than or equal to 0 is true. So right now, all of this is part of our solution. All right, now let's go on and check out greater than that. So let's pick a value, really big value. If you take a really large value and subtract 3, it's going to be positive, but you're going to multiply times a negative 2, so you're going to get a negative on the top. You take a really, really large number and you add to it, you're going to get a positive on the top. So this is positive and a negative, so you know that this output is negative. All right, and so is a negative greater than, is a negative number greater than 0? No, it is not greater than 0. So your solution is in between. So right now, we could say our solution is between negative 2 and 3. Oh, but wait, we need to double check our critical values. All right, so if I plug in negative 2, what happens? I plug in -2 and immediately my I goes to the denominator, which would create an undefined term. So -2 obviously cannot be part of our solution set. -2 cannot be part of our solution set. I wrote this. So -2 would have a parentheses. What about 3? If I put a 3 in the top, I get a 0. 0 over anything is 0. Is 0 greater than or equal to 0? Yes, it is. So, therefore, this would also be a solution set. I'm sorry. 0 is not greater than, or yes, greater than or equal to 0. So this would be included in our solution set. So you would get a bracket around the 3. All right, that's pretty much it. You might need to pause and go back and rewind and watch this a few times just to make sure you really understand it, and then make sure you're practicing hard in class. There will be something on Thursday probably to finish. I'll pull up some particular problems I want you to finish by the end of class, and then that way Thursday night we can go ahead and start on our last section of this, and we want to finish that up on Monday. Instead of having the test Tuesday next week, I think we'll have it Friday. That'll give you a few more days to get questions answered and get caught up, but at the same time on Tuesday we'll be moving on to the next section in the next unit. All right, hope you have a great evening, and if you're taking your PSAT tomorrow, good luck, and if you are not seniors, I hope you have a nice morning in. Talk to you later. Night, Bearcats.